Um, Hello everyone. In this final project, I will be demonstrating how we can build a simple and easy AI conversation agent using Olama and Amazon Bedrock. This conversation will happen via a gRPC server. The Olama will be deployed on local. And the gRPC server will be hosted on AWS EC2. I'll use the Lambda function to call Amazon Bedrock, which then interacts with our AI model. The model I've used is Amazon Titan. I've exposed the Lambda function with an API using the API gateway. Now let's get started. Our project consists of two key components. First is the conversation agent, and another is the gRPC server. Both of the projects you can see on the screen and the project structure as well. Here's a quick overview of how they work together. The conversation agent handles the user queries, interacts with the Olama model running on localhost. It processes the response that is received from the gRPC server and then saves the conversation history. While the gRPC server, it takes these queries, it forwards them to AWS Lambda, which calls the Amazon Titan model to generate AI responses. If we can see the sample output here, you will notice here's what a sample output looks like. Uh, the client, so I as a user will initiate first query, tell me something interesting about whales, and then this query is sent to my AWS uh, Titan model, which is running on Amazon Bedrock. And the response that is received from the Bedrock is then feed into Olama model, and that's how the conversation between those two models happen. Okay, now let's see how the conversation agent uh, is looks like. As you can see, the conversation agent is built using the Akka framework, and it has the following features that it generates AI-powered responses using Olama model. The model I've used is Llama 3.2. The conversation history is saved as a YAML file, and the Olama model itself is highly configurable. I can set the temperature, the maximum number of tokens to be generated, the host and port of the model itself. To run the agent itself, I have Dockerized the application, or we can use SBT for local development setups. For now, I will be demonstrating the entire flow of the project using Docker itself. I have created two Docker files. First is Docker Compose Dev and another is Docker Compose Test. Docker Compose Dev is when my gRPC server is running on AWS EC2. And if I want to run my if my gRPC server is also running on local, then I will use the Docker Compose Test file. Uh, Let me go through the application config file for now. As you can see, here is my Olama configuration. The host is host Docker internal because since I have to bridge the connection between the my local host and Docker, I have used this configuration. My HTTP server configuration, which is the client. My gRPC server, this is my EC2 instance public TNS URL on which my gRPC server will be running. Conversation file will be saved to this location in the Docker volumes. Now, okay. So building the project is straightforward. I will use Docker build LLM client as well as a gRPC server. Now, gRPC server, it's a basic configuration. It accepts the user using gRPC. It forwards them to AWS Lambda to interact with Amazon Titan model, and then it sends back AI generated response. Simple flow. And we already checked how the conversation happened. Now, let's run the project straight away. I will firstly set up, I will get my client image up and running. Now that our LLM client is running, I will send my first query. Tell me something interesting about mammals. All right, let's wait a couple of seconds here so that the conversation is happening in the background and we can check the conversation history that would be saved on the local volume. And there we go. We have the conversation history that is created now, and we can check. Let me wrap this. Soft wrap. This is the first command that I sent from the call command that mentioned something interesting about mammals. And this is how the conversation happened between both these models. As you can see, the conversation is really good. Both of them are like talking like agents with each other and giving appropriate responses to each other. And that concludes the implementation of our conversation agent.